Let's talk about the slope of a line. And in order to do that, I want you to think about riding a bike on a nice sunny day. Yeah, just like that. Okay, so let's imagine you're riding your bike along this road. Now, if we think from left to right, the road's going downhill, and this is going to be a really easy ride. When we're looking at a road that goes downhill from left to right, we say that it has a negative slope. What if our road looks like this? Well, if we're riding from left to right, it's going to be a little bit harder to ride, but we can still do it. If our road's going uphill from left to right, we say that it has a positive slope. Now, what if our road's not going uphill, not going downhill, it's just a nice flat road? That's a pretty easy ride, isn't it? We would say that that road has a zero slope. And one last road. What if it looks like this? Ride your bike and... oh, can't be done, can it? If the road is vertical, we say that it has an undefined slope. Now, knowing whether a road slants uphill or downhill is part of what we're going to look at. But the other part is coming up with a number that can measure how steep that road is. And in order to do that, we're going to put our road on a coordinate system. Now, I want you to ride your bike along the road and stop somewhere. Okay, perfect. Let's mark where your front tire is. Now go a little bit further. Stop there. Good. Now let's mark where the front tire is again. We'll make two measurements. We'll measure the vertical change between the 2 points and the horizontal change between the 2 points. So the vertical change is 1, the horizontal change is 2, and if we make a ratio, a fraction out of those two, the vertical change over the horizontal change, we'll have a number that describes the slope of the road, in this case, the slope of the line. Now remember we said that the road had a positive slope? Well, the line has a positive slope as well. So a line that has a positive slope will look like it's going uphill from left to right. Now you may be wondering, is there something special about the 2 points we chose? Well, not really. We can choose any 2 points on this line to measure its slope. So let's say we chose this point and this point. We could still measure the vertical change and the horizontal change between the 2 points. And if we make a fraction out of those, 3/6, and simplify that fraction, we still get the same slope of 1/2. So a line has a constant slope. You can choose any 2 points on the line to find out what that slope is. Let's try another one. Now we're going to pick 2 points that are easily identifiable. In other words, they fall where these grid lines intersect. So we've got the points 3, 6, and 5, 3. Now the vertical change in this case is actually negative because we're moving down to get from 3, 6 to 5, 3. And our horizontal change is still positive because we're moving to the right in the positive direction. Our slope then is the vertical change divided by the horizontal change, which is -3/2. You remember we said that if we had a line that looked like it was going downhill, that it would have a negative slope. And sure enough, this line does have a negative slope. Now how about this line? It's a nice horizontal line. We can still find 2 points on the line. We'll choose 1, 4, and 7, 4. We're still going to look for the vertical change and divide it by the horizontal change to move from one point to the other. In this case, there is no vertical change, so the vertical change is 0. The horizontal change from 1 to 7 is 6. So our slope is 0, the vertical change, divided by 6, the horizontal change, which is equal to 0. And you'll remember we said that a horizontal line, that horizontal road, had a 0 slope. Now there was one more road we looked at. It was a vertical road. Let's pick 2 points on this vertical line. So we'll go with 2, 1, and 2, 6. And let's figure out the vertical change from one point to the other. Well, the vertical change from 1 to 6 is 5. And the horizontal change is 0. We don't go anywhere horizontally to get from one point to the other. So the slope is the vertical change of 5 divided by the horizontal change of 0. 5 divided by 0 is undefined. You cannot divide by 0, which is why we say that this line, this vertical line, has an undefined slope. So that's all there is to it. If we've got a line, we can just do some counting to figure out what that vertical and horizontal change is between points on the line. It makes a lot of sense, right? You can just use the picture. So vertical change of -3 divided by horizontal change of 2. Slope of this line is -3/2. Simple. But what if I take the graph away from you and just give you the points? Can you still find the slope of the line? Well, you can. You just need to find that vertical change and horizontal change in a different way. We'll do it by organizing the information about the 2 points in a table. It just is going to make it a little easier to understand what's going on. For the vertical change, our y-coordinates are going from 6 down to 3. So the change in those y-coordinates would be 3 minus 6. The x-coordinates are going up from 3 to 5. So the change in the x-coordinates is 5 minus 3. And if we simplify, 3 minus 6 is -3, and 5 minus 3 is 2, we get a slope of -3 over 2, and if you prefer, call it -3/2. So even without a graph, all we're doing is finding the difference in the y-coordinates and dividing that by the difference in the x-coordinates to get the slope of the line. Let's try one more. We've got the points 4, -2 and -7, 5 on a line, and we would like to know what the slope of the line is. So we'll just find the change in the y-coordinates, the vertical change. So we're moving from -2 up to 5, so 5 minus -2 would be the vertical change. And then the x-coordinates, we're going down from 4 to -7, so -7 minus 4 would be the change in the x-coordinates, the horizontal change. So our slope is 7 over -11. So you see, you don't need the graph to find the slope of the line. If you have it, maybe you can just count the vertical change and horizontal change between 2 points. Even without that, just go ahead and subtract your y-coordinates and subtract your x-coordinates, and you'll get the vertical change divided by the horizontal change.